to the video lecture series of Grade 10 Physics. Today we will discuss the lesson Electricity and the topic is Resistors. What is a good conductor? A good conductor means a conductor or a component of size, given size, that offers a very low resistance. Is called a good conductor. So because of low resistance, the electricity can be flow smoothly through the conductor. Then what is a resistor? A resistor means a conductor having some appreciable resistance. That is a resistor. Now, what is a poor conductor? A poor conductor means a component of identical size that offers a higher resistance. So here the resistance will be very high. So it can be called a poor conductor. So a good conductor will offer a very low resistance, and a resistor can offer an appreciable resistance, and a poor conductor will offer a higher resistance. So these are the classification of conductors, resistors, and now we will be looking into the connection of resistors. How we can connect the resistors? So resistor can be connected in two ways. One is series and the other one is parallel. So today we are going to discuss about resistors in series. Let us see how we can connect different type of resistors in series connection. Look at the picture given here. There are three resistors connected. One is R1, second one is R2, and the third is R3. Okay, and these three resistors are connected one after the other. This kind of connection in the circuit is called resistors in series. And these three resistors having resistances R1, R2, and R3. So here we have three resistors, and these three resistors are connected one after the other. So this type of connection is called a series connection. So when you look at this connection, you can understand that there are three voltmeter. So V represents the voltmeter. There are three voltmeter is connected in series. So V1, the resistor, the first resistor will have a voltmeter V1, the second one will have V2, and the third one will have V3. Which means there are three voltmeter is connected for three resistors. So what is the meaning of this 3 voltmeter? What did you understand from this? This is actually meaning that in a series circuit, the potential difference will be different for each resistor. That's why there are 3 voltmeter is connected in 3 resistors. But what about the current? But the current will be same flowing through the entire circuit. So in a series circuit, you need to understand two things clearly. The first thing is that current will be same in the circuit. In a series circuit, current will be same, but potential difference V will be different for each resistor. So I will be same, but V is the potential difference, that will be different for each resistor. Now, when you apply Ohm's law in this entire circuit, the Ohm's law equation is V is equal to I by I into R. So for each potential difference, the resistance is different. So V1 is equal to I into R1, and V2 is equal to I into R2, and V3 equals I into R3. And if you add all these potential differences together, you will get IR is equal to IR1 plus IR2 plus IR3. So when you cancel this I, which is common, because this is same current is flowing through the entire circuit, you will get the effective resistance RS. Okay, so RS is the effective resistance in series circuit, is equal to R1 plus R2 plus R3. So this is the equation which is used to calculate the effective resistance in series connection. RS represents the effective resistance or equivalent resistance in series connection. So which is a sum of the individual resistance. So in series connection, you need to understand how do we calculate the total resistance. Then second thing, which one is varying and which one is constant in the series connection. The current will be same and the potential difference will be varying. Now, we can solve one numerical based on this series connection. Okay, a conductor of 4 ohm is connected in series with another conductor of 8 ohm. So there are two conductors. One is having resistance 4 ohm. The second one will have the resistance 8 ohm. So here we can tell R1 is equal to 4 ohm and R2 is equal to 8 ohm. Now, a potential difference of 6 volt is applied across the combination. So potential difference given here is V equals 6 volt. Now, calculate the total resistance of the circuit, current through the circuit, and potential difference across each division. So, we can take one by one. The first one is we need to calculate the total resistance of the circuit. So, what is total resistance? Total resistance RS, total resistance or equivalent resistance, is equal to RS is equal to R1 plus R2. So, which equals 4 ohm plus 8 ohm equal to 12 ohms. Now, second part, current through the circuit. So, what is the equation for current? According to Ohm's law, I is equal to I equals V by R. So, potential difference is given. Potential difference is equal to 6 volt divided by what is R. R is the equivalent resistance now, that is 12 ohm. Okay, so 6 by 12, which means 1 by 2 equals 0.5 ampere. Now, the third one, question number C, potential difference across each division. So, there are two conductors here, each with the different resistance. One will have 4 ohm resistance and another will have 8 ohm resistance. So, what you have to do, you need to calculate potential difference across each conductor. So, V1 is equal to IR1. Similarly, you can calculate V2. V2 is equal to IR2. Okay. So, I is already we have calculated. I is 0.5 ampere into the first resistance. First resistance is 4 ohms. So, into 4 ohm. And in the second case, IR2, current is same in both cases because this is series connection. So, 0.5 ampere into R2 is equal to 8. Okay. So, in the first one it will be 0.5 into 4, that is 20, which means 2 volt. The second case it is 0.5 into 8, that is 40, so which means 4.0, that is 4 volt. So when you add, you will get a total voltage will be, total potential difference will be 6 volt.